Okay, for this video in 6.0b, we're going to be proving a lot of theorems that have to do with angles and parallel lines. So in this video will actually be separated into several videos, just so that you can take it section by section and hopefully it doesn't get too confusing. So for those of you who are on home study and watching these videos from home, make sure to not get overwhelmed. You could maybe take this video in parts, take a break in between them, but yeah, just make sure that you watch all the videos because I'm gonna stop. I'm gonna do this into sections. So the first part of this video, if you want, you can go ahead and do a review of the UNO proofs like we covered last time, and make sure that you're using the two-column proof format that we talked about, because we're going to keep using that today. So go ahead and do that review if you feel like you need to. But I'm going to jump here to the definitions here. So complementary angles. Now, complementary angles are two angles whose sum is 90 degrees. So, for example, here is a degree that's here's an angle that's 90 degrees, and let's say we have this angle right here. Let's call this, say that this angle is 35 degrees. Well, because we know that this is a 90-degree angle and this part is 35 degrees, this helps us to determine other angles because they are complementary. So this angle must be 90 degrees, subtract 35 degrees. So that's a complementary angle. These two are called complementary angles. A supplementary angle is similar to angles whose sum is 180 degrees. So again, here's an angle, or here's a line, and lines have 180 degrees. So if this were split into two, this would help us determine the two angles given one of them. Now, definition of congruence. Definition of congruence is when two figures or objects are congruent if they have the same shape and size. So you'll see, you'll hear me use congruent a lot today. So when two figures or objects have the same shape and size. Same shape and size. So we use this to talk about shapes, we use this to talk about length, we use this to talk about angles. So we'll be using that quite a bit. Now let's talk about the linear pair postulate. A linear pair postulate, first of all, a linear pair is when you have two angles with one line, pretty much. So like this right here, this angle 1 and this angle 2, these make up a linear pair. So here, if we have a straight line and it's cut by another line, then these two angles make up a linear pair. Now, the linear pair postulate just states that a linear pair is supplementary. A linear pair is supplementary. So again, these two angles right here, they make up a linear pair. And so from this postulate, it tells us that these two angles added together is 180 degrees. That's what it means to be, that's what supplementary means. So that is the linear pair postulate. Now, let's go through what this diagram shows. So in this diagram, A and M are parallel, and we write that by saying A, and then we draw two lines and M. So this right here means A and M are parallel. And this line right here cuts through both of them, and we call this line T, we call it the transversal. The transversal. So A and M are parallel lines, and T cuts through them, and T is a transversal. Now, what this does is it creates a lot of angles for us, and it helps us know which angles we can compare and which angles are congruent. So angles 1 and 2, like we already talked about, we call these the relationship between these two are a linear pair. Angles 1 and 2 we call a linear pair. Angles 1 and 5, so here and here, we call these corresponding angles. Okay? Call them corresponding angles because you see how, again, this is a line, and they're both parallel. They're in the same position in respect to their lines being cut by the transversal. So that's why we call them corresponding angles. Now here's the thing, they're not the only corresponding angles here. Angles 1 and 5 are corresponding, but also 2 and 6 are corresponding. 4 and 8 are corresponding. 7 and 3 are also corresponding. So you can go ahead and add that too, as in pairs. So 1 and 5 we know are corresponding, also angles 2 and angle 6. Angles 4 and angles 8. Also angle 7 and angle 3. These are also corresponding angles. And likewise with the linear pair, these aren't the only linear pairs that we have, angles 1 and 2. Also 1 and 3 are also linear pairs. 4 and 2 are linear pairs. 3 and 4 are linear pairs. And you can do the same thing with these sets of angles right here. These are all linear pairs. So if you want, you can feel free to also write down other linear pairs and corresponding angles, and as we go on you'll see the same occurs. So angles 3 and 6 right here. So notice that, well, we call these angles right here, so angles 3, 4, 5, and 6 are called interior angles. So 3, 4, 5, and 6 are interior angles, while angles 1, 2, 7, and 8 are exterior angles. Okay? So angles 3 and 6, we call them alternate interior angles. They are alternate interior angles is because we go from 3 to 4, but then 4 to 6. So if we were to draw like a circle in this order, 3, 4, 6, and 5, alternate means every other, right? So we're going from 3, we're skipping 4, and we're going to 6. So we're alternating. And they're inside, so we call them interior. So 3 and 6 are alternate interior angles. 4 and 5 are also alternate interior angles. So alternate interior angles. Now 1 and 8 are alternate exterior angles. Alternate exterior angles because they're on the outside, and again, if we're looking at the exterior angles, we go 1, 2, 8, and 7. So these are alternate, and also 7 and 2 are alternate exterior angles. Okay, now 4 and 6 are what we call consecutive interior angles. Consecutive interior angles. You might also hear adjacent interior angles. There's a lot of different, there can be different names for these, but for our purposes, I think we mainly stick to consecutive interior angles. Now, they're consecutive because, again, if we draw that little circle, we have angles 3, 4, 6, and 5, right? If we're drawing them in clockwise order. Well, 4 and 6 are in consecutive order and they're inside, which means also 5 and 3 are also consecutive interior angles. And then 2 and 3, or sorry, 2 and 3, we call these vertically opposite angles. Or in short, we usually just refer to them as vertical angles. Now, we call them vertical angles because they are just vertically the direct opposite of each other. So 1 and 4 are also vertical angles. 5 and 8 are also vertical angles. 7 and 6 are also vertical angles. Okay, so that should pretty much do it for this first page, and we are going to be using these ideas, and we're going to be proving the relationships between all of these in the upcoming videos. So make sure that you keep going through, maybe take a break, but watch the other videos that are coming up.